In this video, we're going to investigate the relationship between rectangular and polar coordinates. We're then going to learn how to convert back and forth between the two types of coordinates. So consider the polar and rectangular coordinates together. The polar axis is going to coincide with the positive x-axis, and the pole coincides with the origin. A point P, not at the origin, has a rectangular coordinate of xy and a polar coordinate of r theta. So we're going to use this little diagram I have here to understand the relations between rectangular and polar coordinates. I want to make sure we can still see our diagram. So if a point has rectangular coordinates of xy and polar coordinates of r theta, then these coordinates are related as follows. X is equal to r times cosine theta. Well, that's nothing new. We already know this. Let's look at our diagram. What we have here is a right triangle. So our right angle trig applies. SOHCAHTOA applies here. And if we think about SOHCAHTOA, cosine of that angle theta is going to be equal to our adjacent over our hypotenuse, x over r. And if we just solve this equation for x, multiplying r on both sides, we get x to be r times cosine. So that's our first relationship there. The next one is y equals r sine of theta. Oh, I'm going to go back to my right triangle here in SOHCAHTOA. Sine, we know, is our opposite over our hypotenuse, y over r. And if we solve this for y, we get r sine of theta is equal to y, and that's our second relationship. You'll see I've noted here that we use these two usually when converting from polar form to rectangular form. And that makes sense because x and y are solved, and that's what we need for our rectangular coordinates. All right, I'm going to just continue with my SOHCAHTOA here. We know that tangent of theta is equal to opposite over adjacent, so that's going to be y over x. And that's our fourth relationship. And then the last relationship doesn't even come from trigonometry. It comes from the Pythagorean theorem, relating the three sides of a right triangle. So x squared plus y squared is going to be equal to r squared. And we're going to use these second two relationships when we're converting from rectangular form to polar form. All right, let's determine the rectangular coordinates of each point that's given in polar coordinates. And the way that you know that it's been given in polar coordinates is that your second one's going to be an angle measure. So you're either literally going to see the degree symbol or it's going to have a pi in it. And we know we typically don't see pi in rectangular coordinates. Using our first two formulas, x is going to be equal to r, which is 6, times cosine of 30 degrees. And then our y value is going to be 6 times sine of 30 degrees. So this is going to be 6 times square root of 3 over 2. And this is going to be 6 times a half. So we're getting x is equal to 3 square root of 3. And y is equal to 3. Now just make sure that you write this as an ordered pair in your final answer. 3 square root of 3, comma 3. Next, let's convert negative 4 comma 7 pi over 4 to rectangular coordinates using the same two formulas. X is going to be equal to r times cosine of theta. And y is going to be equal to r times sine of theta. Cosine of 7 pi over 4 is a positive square root of 2 over 2. And sine of 7 pi over 4 is a negative square root of 2 over 2. So we get x to be negative 2 square root of 2 and y to be positive 2 square root of 2. And again, make sure that you're writing that as an ordered pair for your final answer. And there we go. Now let's go the other direction. So we're going to be using our other two formulas. We're going to use r squared is equal to x squared plus y squared, and we're using tangent of theta is equal to y over x. So we'll start by getting r. We'll use our first formula. R squared is equal to 2 squared plus negative 2 squared. So r squared is equal to 4 plus 4. R squared is equal to 8. But we want r, not r squared. So we'll take the square root of both sides. And we get r to be 2 square root of 2. Next, we need to find the theta. Here we're going to be using tangent of theta is equal to y over x. That means that tangent of theta is negative 1, and theta is going to be tan inverse of negative 1. All right, well, we know that tangent is 1 when we have a 45-degree reference angle, and since its tangent value is negative, we need to be in either the second or the fourth quadrant. So that means that we can choose from an angle in the second quadrant at 45 degrees or in the fourth quadrant at 45 degrees. When going from a rectangular to polar, we have to keep this in mind. Think about where this is. You know how to plot rectangular. You've been doing that for a long time. So this is 2, negative 2, so positive in the x, negative in the y. So this point here is in quadrant 4, so we need to figure out, well, what angle measure puts us in quadrant 4, so we need the one down here. And because of coterminal angles, we have two options. We can use negative pi over 4, or we can use 7 pi over 4. It doesn't make a difference, because with polar, we know there's an infinite number of correct answers. So I think I'm going to use 7 pi over 4. This is going to be 2 square root of 2, comma, 7 pi over 4. I don't like to use negatives if I don't have to. All right, let's try another one. R squared is equal to x squared plus y squared. R squared is going to be 1 plus 3. R squared is 4, making r equal to 2. Moving on to our angle measure, our theta. We're using tangent of theta is equal to y over x. Tangent of theta is square root of 3, meaning that theta is tan inverse of the square root of 3. So we got to take a look here. Figure out where tangent is equal to square root of 3. That happens when our y value is square root of 3 over 2 and our x value is a half. And since we're looking at a positive number, we got to be in quadrants 1 or 3. So we got these triangles here with a 60-degree reference angle. We got to figure out which one we want. Think about what quadrant this is in rectangular. -1, -3 Puts us down here in the third quadrant. So that means this is the angle we're looking for. 180 degrees plus 60 degrees is 240 degrees. We can write it like this, or we can write it in radian, which would be 4 pi over 3. It doesn't matter, just make a choice. I think I'm going to write it in radian. We get the 0.2, 4 pi over 3.